What if we could target the real basis of cancer for a cure? A question that has been burning in the minds of scientists for more than a century. The search for an answer has led to various breakthroughs in cancer research, each one bringing us a step closer to the elusive cure. The journey began with Otto Warburg, a pioneer in cancer research. Warburg discovered that cancer cells have a peculiar addiction for glucose, consuming it even in the presence of oxygen, a process known as the Warburg effect. This discovery led to therapies based on this effect, such as the keto diet for cancer patients. However, the efficacy of these therapies has been less than ideal. Despite this, the Warburg effect has been instrumental in the development of PET imaging. By injecting a radioactive form of glucose into patients, doctors can detect cancer with high resolution. But as it turns out, there is a more potent addiction in cancer cells, one which lights up PET scans even brighter: methionine. Methionine addiction in cancer cells, known as the Hoffman effect, was discovered by Robert Hoffman nearly half a century ago. Unlike glucose, cancer cells are highly addicted to this amino acid. So, how can we exploit this addiction to cure cancer? The answer, surprisingly, is quite simple. Put the patient on a low methionine diet and supplement it with an enzyme that breaks down methionine. This enzyme, methioninase, can be taken orally and stays in the gut for hours. Once meal digestion starts, methionine is released from proteins in the food and is degraded by methioninase. But this alone is not enough. In most cases, chemotherapy is also required. Though it might only have marginal effects on its own, chemotherapy has been found to be highly effective when cancer cells are starved of methionine. The results so far are promising. We've seen a patient with metastatic rectal cancer who had previously failed chemotherapy, completely cured after adding methioninase to her treatment. We've regressed brain cancer in children, a feat previously thought almost impossible. A breast cancer patient with axillary lymph node metastasis saw her condition disappear after receiving chemotherapy combined with methioninase. Even a stage 4 pancreatic cancer patient is still alive after 2 years, a rare occurrence indeed. In conclusion, the potential of targeting methionine addiction for cancer cure is immense. From the Warburg effect to the Hoffman effect, the journey of cancer research has been long and arduous. But with the current breakthroughs, we may finally be on the brink of finding a general cure for cancer. Remember, the real basis of cancer is methionine addiction, and targeting it could be our best bet in the fight against this deadly disease. Voiceover. Let's take a moment to appreciate the efforts of Anti-Cancer Inc. in this groundbreaking research. This company has been at the forefront of the development of methioninase treatment, tirelessly working on perfecting the technique, conducting rigorous trials and pushing the boundaries of what we thought was possible. Their commitment to finding a cure for cancer is unwavering and their dedication palpable. They've not only developed a potential treatment, but also given renewed hope to millions of patients worldwide. Their pioneering work in understanding and targeting methionine addiction has brought us a step closer to potentially finding a general cure for cancer. In the face of this deadly disease, their innovative approach and relentless pursuit of a cure is truly admirable. Remember, the real basis of cancer is methionine addiction, and targeting it could be our best bet in the fight against this deadly disease. And with companies like Anti-Cancer Inc. leading the charge, we might just stand a chance.